Hi class. Today we're going to look at some deductive argument patterns that you did in the reading, mostly related to conditional arguments, if-then arguments. Something that I think is important to note, and this is sort of a deeper philosophical point. Logic seems to exist in the very nature of things. That is, we don't create logic, we discover it. We discover relationships that hold universally, that we can make connections and expand beyond that. It's very much like math in this way. And as a Christian, it begs a deeper philosophical question. Why do we live in a universe that's inherently mathematical, where math allows us to build bridges, get to the moon, use smartphones? I mean, we didn't create math. It works in the world. We discovered it. The very nature of our reality, every physical law, gravity, whatnot, has a mathematical structure and formula. Why? And to say that it's accidental or random seems less compelling to me than design or creator. Well, logic is similar. There are logical principles that exist that hold all the time, that help lead us towards the truth, that help us find, falsehoods, and these are things that we discover and that seem to exist. We live in a universe that's mathematical. We live in a universe that's logical, that's rational. In fact, our language can't avoid it. Any language, right, that you might speak will have an equivalent of the conditional, the if-then. And that creates logical relationships. So language itself is embedded in logic because logic is what allows us to understand each other. Logic is what allows language to make sense, to be translatable into, right, from French to English or whatever. There has to be a particular grammar, a particular logic to the way it's structured so that it makes sense. And if-then language creates a logical relationship between the antecedent, that's the first part, the if, and the consequent, which is the second part after the if. So an if-then is made up of an antecedent and a consequent, and they're in a particular relationship to each other. So anytime I say if X, then Y, if A, then B, I'm creating a logical relationship between A and B, and here's the way the relationship works. If I say if A, then B, A is the antecedent, is a sufficient condition for B. When I say a sufficient condition, I mean all I need to know to have B is that I have A. A is sufficient to know that I have B. It's all I need. A might not be necessary for B. A is often not necessary for B, but it is sufficient for B. I'll give an example. I'm at the movie theater. I want to buy 2 tickets. The cost is $20. I have a $20 bill in my wallet. Having a $20 bill in my wallet is sufficient for buying the movie tickets. It's all I need to get the tickets is that $20 bill. But having the $20 bill is not necessary for me to buy the tickets. It's not necessary because I have a credit card and I can just swipe my credit card and get the movie tickets that way. So having the $20 bill is sufficient for getting the movie tickets. A is sufficient for B. But having the $20 is not necessary for me to get movie tickets because I can get them a different way, right? So sufficiency is not the same as necessity. If I say if A, then B, A is sufficient for B, B is necessary for A. You've got to have B if you're going to have A. B is not sufficient for A, right? It's not sufficient, but it is necessary. You've got to have it. So again, if I'm at the movies and the cost is $20, it is necessary that I have some form of payment to get that $20 price, right? I've got to have some payment. It's necessary to have a method of payment. Okay, the cash is sufficient, not necessary, but some method of payment is necessary. So if A, then B, A is sufficient for B logically every time. B is necessary for A every time. If I'm talking about bachelorhood, maybe it helps, right? To be a bachelor is to be a single male. Okay, so if I am a bachelor, then I am single. Being a bachelor, knowing that if I'm a bachelor, if A, then I am single, B. Bachelor is sufficient for me to be single, right? Bachelor is sufficient for me to be single. Being a bachelor isn't necessary for me to be single because I could be a woman and single, right? So it's sufficient for me to be single, not necessary for me to be single. Being single is necessary for me to be a bachelor. I cannot be a bachelor unless I'm single. I can be single without being a bachelor because I could be a woman, right? But I cannot be a bachelor without being single. Being single is necessary. So sufficiency from A to B, necessary from B to A. Necessary and sufficient is the best, right, option here. So to be a bachelor is to be single and male. Being single is necessary for being a bachelor. Being male is necessary for being a bachelor. Being single and male together are both necessary and sufficient for being a male. So coming up with sufficient criteria and necessary criteria are important, right? There's a logic to the language we speak, and we need to be cautious of that and use it well. It's very powerful, but we have to use it well. So I have some general forms, and we're going to look at this and talk about it, right? So in the book, there are what we call conditional argument forms, right? So I'm going to share my screen. Now, so you want to have these down, right? They're in the book. Conditional argument forms. The first is called modus ponens. Premise 1, if P, then Q. Premise 2, P, conclusion, therefore Q. Anytime an argument is in this form, it is logically valid, logically warranted. Factual is a different story. It depends on what the premises are saying. But logically, this is in the right structure. Another word for modus ponens is called affirming the antecedent. Affirming the antecedent, because we're saying if P then Q, P is the antecedent, Q is the consequent, then we affirm P, and at the conclusion is we affirm Q. So because we affirm P in premise 2, we call it affirming the antecedent, okay? P is a sufficient condition for Q logically. Q is a necessary condition of P, but not sufficient. And so this should help as we go through. So the example I use is one where we have true premises, right? That will help. Premise 1, if it is raining, then it is cloudy. Rain is the antecedent, cloudy the consequent. Rain is sufficient for clouds. If it's raining, then I know it's cloudy. Knowing that it's raining is all I need to know that it's cloudy. It's sufficient. Rain is not necessary for it being cloudy though, right? It can be cloudy without it being rainy. So rain is sufficient for clouds. It's not necessary for clouds. Cloudy is the consequent. Cloudy is necessary for rain, but it's not sufficient for rain. You've got to have clouds to have rain. So clouds are necessary. But clouds are not sufficient because you need clouds and other weather features, certain pressure, precipitation, all that kind of stuff to get rain. So it's necessary for rain, not sufficient. If rain is sufficient for clouds, right? If P is sufficient for Q, if it's raining, then it's cloudy. If I affirm that it's raining and rain is sufficient for cloudy, then I can conclude with necessity that it must be cloudy. If rain is sufficient for clouds and I know it's raining, then I know that there must be clouds by necessity, okay? Next formulation, modus tollens. It's also called denying the consequent, denying Q. Again, the names come from premise 2. Not Q is denying the consequent, and that's why we call this form. Anytime you see this logical form, excuse me, every time it is valid. It is in the right logical structure. The truth of the premises is another question, but in terms of form, it's right. If P, then Q, not Q, therefore not P. Okay? So we look at it in our example. If it is raining, then it is cloudy. If clouds are necessary for rain, you have to have clouds in order to have rain. And we say, but we know it's not cloudy, and clouds are necessary for rain, then we can conclude with certainty that it is not raining, right? If it is raining, then it is cloudy. It's not cloudy, therefore it's not raining. This should make sense to you because we have to have clouds in order to have rain. That's the necessary condition. It's in the consequent position. Language has a particular logic to it. So anytime you see an argument in this format, you know it's in the right logical structure. I want to cover two fallacies related to these logical forms. One is called denying the antecedent. So we're not affirming the antecedent, now we're denying it. Look at premise 2. We're saying not P, denying it, right? So the generic form is if P then Q, not P, therefore not Q. Many people intuitively say this must be valid. This looks very similar to the others we've been covering. It's not. Every time an argument is in this format, it's a fallacy. And I'm going to show you with the rain example because it's really easy. If it is raining, then it is cloudy. It is not raining, therefore it is not cloudy. That's not true by necessity. It's possible for it not to be raining and yet still to be cloudy, right? There are many cloudy days where there's no rain. So you look at it and you realize that it's not the case. Now, here's why. Rain is sufficient for clouds, but it's not necessary for clouds. So you can deny that it's raining and still have clouds because while rain is sufficient to know it's cloudy, it's not necessary to have clouds. You can have clouds without it. So because of the way we've structured our language with the if-then, the way logic works, this is a fallacy each and every time because it's supposed to be deductive, but the conclusion does not follow from necessity, from the premises, right? The other fallacy is called affirming the consequent. Again, look at premise 2. We're affirming Q, which is the consequent, which is where the name comes from. If P then Q, Q therefore P. Looks good, seems right, it is not. Any argument in this form is not logically warranted. Again, if we use the same example, if it is raining, then it is cloudy. It is cloudy, therefore it is raining. No, not necessarily, maybe, but not by necessity, which is what deductive arguments are supposed to do. We know that clouds are necessary for rain, but they're not sufficient for rain. Simply affirming cloudy does not affirm rain because cloud's not sufficient, only necessary. But we may need other things too. Like single was necessary for bachelor, but not sufficient. We needed single and male to get the sufficiency. So we can't just affirm cloudy and by necessity affirm rain. That's not how it works. So I hope these argument strategies are helpful. You might need to pause me, go back, look at them again. I'm going to want you to be able to identify these in practices, create them, critique them, right? And so you'll want to make sure that I'm going to look at some more complicated forms. Extend this. We're going to look at or arguments. The or arguments are called disjunctive arguments, this or that. Right? Something I need to say, though, is that you can have inclusive or and you can have an exclusive or. Most of you are familiar with the exclusive or, which is you either do this or you do that. It has to be one and only one. But that's the more rare kind. Much of the time, the or is inclusive. And in fact, I want you to assume the or is inclusive unless I tell you otherwise. Okay? So inclusive or means one of these must be true, but both can be true. Okay? An inclusive or means one of the pairs must be true, but both can be true. In an exclusive or, one and only one can be true. Okay? So I'm going to look at inclusive or first. Here are the forms. P or Q. Not P, therefore Q. That's valid. One has to be correct. P or Q means one of those has to be true. If P is not true and one of them has to be true, then it must be Q. The next one over to the right, premise 1, it's P or Q. Premise 2, not Q. Conclusion P. Again, valid every time, logically valid. If one of those has to be true and Q isn't, then it must be P. If you play the game of Clue, and you know that it has to be either Mr. White or the butler that committed the crime, and you learn it is not Mr. White, then it has to be the butler, right? Fallacies related to inclusive ors, if you say P or Q and then you affirm P and you say therefore not Q, intuitively you might say that's right, but it is not, because both can be true. The inclusive or simply says both cannot be false. One must be true and maybe both. So affirming P does not by necessity exclude Q. So that's a fallacy of the inclusive or. To the right, if you affirm Q, that doesn't mean you get to deny P, because both may be true with an inclusive or. Exclusive or is different, right? An exclusive or, like this, one and only one can be true, which means you can either deny or affirm one and still get a valid conclusion. Okay? So those ones on the bottom there, P or Q, P therefore not Q, they are not fallacies with the exclusive or, because only one can be true. You affirm one means you have to deny the other. Okay? So some inclusive or, right? Examples. This is inclusive. I will work on my paper or I will read pages 25 to 50. I worked on my paper, therefore I did not read pages 25 to 50. This is a fallacy. It's assuming that you can't affirm both. With an inclusive or, you can, right? By affirming that you did your paper does not deny that you read the pages, because both might be true. So this is a problem. Now, if it was an exclusive or, where one and only one could be true, then this would be valid. This is better for an inclusive or. I will work on my paper or I will read pages 25 to 50. I did not work on my paper. Since one of those two things has to be true in premise one, I know I can affirm that I read the pages. This would also be valid with an exclusive or, because one and only one is true of the couplet. So disjunctive arguments are or arguments. Again, if you say this or that, logically you're saying one of these has to be true, and maybe both are, right? Okay, so a little bit longer examples here. So I want you to stay with me. Maybe you need to pause, get a drink, go to the bathroom. But I think this stuff is important. A constructive dilemma, right, combines disjunctive argument with conditional arguments, okay? So premise one is P or Q. So that's your disjunctive premise. It's an or statement. One of those needs to be true. Then premise two, if P, then Q. Premise three, if R, then S. Since we know either P or R must be true, P is sufficient for Q and R is sufficient for S, then we know we need with certainty that we're going to get Q or S, right? If P is true, we're going to get Q because P is sufficient for Q. If R is true, then we're going to get S because R is sufficient for S. So P or Q means we're at least going to get Q or S and maybe both, right? So we're starting to build longer arguments that are going to help, right? An example from theology is something like this. This is a very famous argument, by the way. It's called the ontological argument for God's existence. God either exists or God does not exist, right? It seems pretty plausible. If God does not exist, then God's existence is impossible. Premise three, if God does exist, then God's existence is necessary. God has to be if God exists. Conclusion, God's existence is either impossible or God's existence is necessary. What do you think comes next, right? How do you think the argument will expand? It's a very long argument. What I want you to see here is that this is a disjunctive argument, or excuse me, it's a constructive dilemma that starts with a disjunctive premise and then has two conditionals. In this case, premise one is exclusive. It's an exclusive or. God cannot exist and not exist. Only one of those two things can be true. One and only one of those things can be true. It's an exclusive or, okay? But we come up with God's existence is either impossible or necessary. The next part of the argument is God's existence is not impossible. There's no logical contradictions that make God's existence impossible. There's no proof that makes God's existence impossible. Well, if our only options are that God exists by impossibility or God exists necessarily, we get rid of the impossible. Now God must exist by necessity, right? And so it's a proof for God's existence using logic. A destructive dilemma, a slightly different dilemma. So a constructive dilemma, I'm going to go back. A constructive dilemma uses modus ponens, affirming the antecedent. P or Q, if P then Q. If P is true, we get, right, affirming the antecedent, which means Q must be true. If we get R, then we connect R to premise 3, and we see modus ponens there affirming the antecedent, and we must get S. So there's kind of a combination here of logic, of disjunction, and then affirming the antecedent. A destructive dilemma uses modus tollens, or denying the consequent, which we talked about earlier. So if you have something like if P then Q, if R then S, and we know that Q is false or S is false, then by necessity we know that P must be false or R must be false or both, right? Because if Q is false and Q is necessary for P, then P must be false. And if S is false and S is necessary for R, then R must be false. And since either P or Q, or excuse me, if either Q or S must be false, then we know by necessity that either P or R must be false. An example might be, if Dallas wins, then they will make the playoffs. If Detroit wins, then they will make the playoffs. Either Dallas will miss the playoffs or Detroit will miss the playoffs. Therefore, Dallas will lose or Detroit will lose. Again, you can if you put letters to each of these components, you're going to get the generic form of this destructive dilemma, right? The last argument structure I want to talk about is a hypothetical syllogism. If P then Q, if Q then R, if R then S, therefore if P then S. It's like a very mathematical kind of formula. If P then Q, right, P is sufficient for Q, which means we're going to get Q. If Q then R, Q is sufficient for R. So since P is sufficient for Q and Q is sufficient for R, P now becomes sufficient for R. If R is sufficient for S, and P was sufficient for R, then P now becomes sufficient for S. And if P is sufficient for S, then we can say with certainty, if P, then S, right? If I ride my bike, I will get to the store faster. If I get to the store faster, I will catch it before it closes. If I catch it before it closes, then I will get to buy a Coke, which means if I ride my bike, then I will get to buy a Coke. It follows absolutely by necessity. Again, I would encourage you to come up with examples, practice these, know them, right? Be able to apply them in real world examples. That's going to be really vital. So I hope this was helpful. Have anything from me, please let me know, and I will see you online.